Yeah, I'm the last speaker. This is always a tough spot because everyone's like tired and like it's just been a long conference. So I really appreciate everyone hanging out for this last talk. Okay, cool. So this is building high-performance React applications. This is going to be hard to follow our last speaker. This is shifting gears a little bit, which is a brilliant talk. I loved it. Brilliant. Okay, cool. So let's just get started. So first of all, my name's Joe Karlsson, and that's on my social stuff. But I am a software engineer. I've been teaching JavaScript and React. I currently work at Best Buy in Minneapolis, Minnesota. I'm a tech lead there and do mostly front-end development. All right, cool. And we work with React every single day. So first of all, I want to talk a little bit about why we're covering like React performance and front-end performance specifically, like why this is important. So, why? So my sites are fast enough. Has anyone ever heard anyone say this before? Yeah, I have not. No one's ever said that before. So let's put some hard data on that. So first of all, Google's found that users abandon websites if it doesn't load within 6 seconds, and the number is even shorter on mobile. Right? User retention is extremely fast. And what about e-commerce? So Amazon actually did a study too, and they did some A/B testing on their homepage, and they increased the latency on their homepage by 100 milliseconds. And it resulted in a 1% decrease in their annual sales. Anyone have a guess how much that is for a single year? That's a lot. It's over $1 billion. That's just 1% decrease, right? That's a lot of money. That's a lot of money to be putting on the table, right? So anyway, if you're selling things or have any content ever online, you want it to go fast. So there's 2 places you could speed up a web application. You got the server and the client. So why would you focus on speeding up the client? Well, first of all, it's my opinion that it's simpler. So there's things you can do on the client or the server side, like adding caching layers, optimizing algorithms, et cetera, et cetera, et cetera. But typically, optimizations you make on the front end are a lot simpler than the ones you make on the back end, which I'm going to show you today. Second thing is, too, the second you roll those out, you see immediate results on that. You don't have to wait for caches to fill up. Second you roll out those optimizations, they start optimizing. And lastly, it's cheaper. All right, so I hope I've convinced you. Let's go fast. But let's see, I want to give a little preface too. So this talk, we're not going to be going like deep into the mechanics of React. This talk is going to be mostly about taking home practical tips and tricks for speeding up your apps. And we're going to talk a little bit about why they'll speed it up too. But some of the speakers here have talked a lot about, in much more detail about, like the virtual DOM and other things about React that makes it go really fast. Okay, cool. So the short answer for making your React applications go fast is rendering only when you need to. You want to make sure that it goes, you're only making updates to the DOM when you really need to. So the reason why we have the virtual DOM is because making changes to the DOM is an extremely expensive operation. Making those changes takes a long time. And especially with modern web applications, we're seeing that we're making lots and lots of changes in real time with lots of different data sets on the DOM, which can be extremely expensive. And we need to help manage that on the front end. So that leads us to the long answer. So first of all, whenever you're measuring performance, you need some sort of benchmark, some sort of starting place to start figuring out if you're improving performance or not. And luckily, React in, I think the new version 15, I know 16's out, but since version 15, they've had built-in React performance tools that integrate directly with Chrome, which is amazing. these React perf tools. So if you add $React_perf at the end of any React application in dev mode, and then go into the performance tab in Chrome, you'll see this new user timing. Let's see, where is this? New user timing thing. And this actually allows you to, when you do a performance profile of your React application, you can see how each component gets rendered and how long each part of the application takes. So let me give a background, actually. I've been using React for years. And it's actually only recently that I got interested in React performance, and it was kind of due to necessity. We were building a chatbot on our website, and we found out that after the chat log got to a certain length, the performances started tanking, and we had no idea what was happening with it. I started looking into it, started to figure out how can we figure out what's causing this issue, and that's when we bumped into React Dev Tools. What are we looking at here? So you'll see I'm doing a quick profile of the site. This is a little demo application I put together. If you're following along with the slides at all, this React demo is online on GitHub. You can pull it down and play with it if you want. What we're looking at here is we're making updates to a giant form, and basically this form just has thousands of just data entries that's being put on the DOM, right? And we're seeing here that this reconciliation process for each time it enters it is taking 34 milliseconds. Let's do it again. So I'm putting some entries in here, doing a profile, and then checking out just one update. So see, it takes 34 milliseconds for it to update. And you can see each component down there that it's updating it. The most important thing here we're seeing on the bottom is every single time I enter a new item in this list, every single item in this list is updating on the DOM. Every single item is updating, which seems like kind of a waste, right? We saw with the virtual DOM demo yesterday that React should be only updating new items that are changed, right? It's using that diffing algorithm we talked about. So it should only be appending that one. I should note this demo is written to be the worst React application humanly possible. So we're going to slowly speed it up, kind of go through all the mistakes I made of putting this together. So let's run through this one more time. We're going to use our benchmark here, 34 milliseconds. That's going to be our base mark for updating. And we're going to see if we can get that to go faster. 34 milliseconds. OK, just remember that number. All right, first tip, using key correctly. So keys are used to identify unique elements in a React application. I didn't know this for like years. I had no idea. How this is used is it keeps track. The React diffing algorithm needs some help from you to tell it how you're putting lists together, how you're putting things on the DOM, and you need to give it unique items. So if anyone has put like a map repeater, making like repeating list elements on a React application, you ever see that like, please enter key prop or whatever? Anyone see that error? A couple of people? Yeah, I've seen it. And then who has put something like, just added math.random or added like the index the array in there to make that error go away? I did it for years. Like it goes away and it's fine. Great. Yeah. Turns out that's really bad for React. That turns out that's really bad. Just because the error goes away doesn't mean that that's great for the code. So whenever you're doing like a repeater or mapping over index elements, you never want to use index or the math operator. Those are bad. Another Buffy character. Yeah, don't do that. Don't do that ever again. Cool, so let's take a look at it. So for this app, we fixed that error. And let's check out to see how that affects performance. So remember that 34 millisecond performance we had the first time? Now we're down to about 17 milliseconds. Just doing that has helped the diffing algorithm. It's decreased it by half. It's allowed us to cut that time directly in half, right? Just by making that small change. Just using. So what do you do if you don't use if you can't use index or like a random number that's generated every single time? So typically what you're doing is most of the time what I'm using is I'm getting an API from some backend source, right? And usually you get a unique ID from that backend API for each element. 99% of the time, I can just throw that unique ID on there, and you're good to go. That's a unique identifier that's not going to change even if that data gets mutated. What do you do if there's no ID that comes back from the API? That happens sometimes, right? Or sometimes you construct data on the client side, there's no ID. What do you do? So something I do a lot is I'll use a hashing algorithm and just hash the whole object or part of that object, a unique part of the object, and use that as a unique identifier. If you've never implemented a hashing algorithm, just Google it. There's a lot of great ones online. There's a ton out there. All right, cool. So using key correctly. Next tip is using should component update. So should component update. This is something actually I didn't know about either until I started putting this talk together. But should component update allows you to tell a React component exactly when you want it to render. So you can tell it. So for example, something I do a lot is I'll pass through lots of props from a parent that I get from the back end, and my React component typically doesn't need to know about all those changes, right? So if one of those other changes, like another part of that component changes, I don't want that component to re-render. I only want it to re-render if specific parts of the object or part of that props change. Should component update allows you to specify exactly when that happens. And this is what that looks like. So by calling this method on there, you're able to pass through the next props and next state, and you can compare that to the current props, the current state of the application, and you can make a determination whether or not that component should update or not. This is really useful if you have a really complex props or state, maybe deeply nested. You have maybe a ton of data that you're managing in it, but you only care about specific parts of it for re-rendering. This works really great for it. So let's take a look at the performance implications of adding should component update to our React components. So remember we had 34, then we got down to 16 or 17. And now we're down to 9 milliseconds. So it's specifying exactly when. And just take a look at it too. So we dig into that tree structure there. You're seeing that should component updates being called on the bottom for each one of those instead, which takes a lot less time than doing a full re-render. Let's wait for that one to blow up again. Using GIFs is great because you don't have to worry about your live app breaking, but you can't have as much control over it. Yeah, so it's calling should component update now. And you notice it takes a lot less time to run that update on the compiler. So anyway, down to 9 milliseconds. And we cut that almost in half again. I don't know, it's such a satisfying little GIF. Okay. Ooh, that feels good. Okay. So another tip is using pure components instead of components. So I've been using regular React components for pretty much most of my adult life. So what does a pure component? Yeah, a long time. So pure components, what do they do? So pure components differ from regular React components because pure components do a shallow comparison of all props and states. It's pretty much like doing a shallow should component update for every single component, but it does it for free. It just gives it to you for free out of the box. And shallow, so in computer science, with the concept like deeply nested and shallowly nested, having a shallow comparison means that it only gets like the top layer of props. If you have like a deep structure, which would include like objects within objects, arrays of objects, pure components are not a great fit. But if you have a very simple component, very simple props and state structure, pure components give you free performance benefits out of the box for no work. So let's take a look at that. And you'll notice peer component, right? We're just extending the peer component. This component does the same thing that our last component I showed you with that should component update. That's, where is that? This guy and this guy are doing the same exact thing. That's amazing. That looks so good. I just want to take a moment to sit with that for a second, because that cleaning that up just feels so good, right? You get these free performance benefits with essentially no additional code. Woo! That feels good. I love that GIF. All right. So let's take a look at it. So with this test, we're going to run a profile again using peer components instead of using the should component update. So we should see it's about the same as using the should component update. It's about 9 milliseconds. Yeah. And we see on average it's about 10-ish milliseconds to run that, just replacing it with a peer component. All right, cool. Fast! All right, so I know when I first learned about peer components, my first instinct was to just jump in and just replace every component with a peer component. I would wait on that. So I think it's helpful to kind of put this stuff into context for how we could actually use this stuff. So typically what I do with my React applications is I typically don't do any of this stuff unless I see some performance issues. I'll just use regular components. Next thing I'll do is I'll try to convert it to a peer component if I possibly can. And then I would upgrade using a regular component and should component update if I have a deeply nested props or state. At that point, I would make it a regular component and just use should component update. That's usually kind of the order of operations I go through when determining how to optimize my React applications. Okay, cool. So as many of you guys know, React favors functional data types and structures, including immutable data types. So immutable data types can actually make React applications perform better. So immutable data, in case you don't know, is just a fancy word for making a copy of an object, as opposed to mutating it or changing the original object. Very fancy. And immutability the JavaScript compiler is able to track changes in immutable code. So if you have the old version and the new version, it's able to diff them much better, as opposed to if you lost the old data and just have one set that's been changed. It has to go through the entire set. It's able to make changes if you can do that comparison much faster. Okay. So building for production is also incredibly important too. So with your development modes, with Webpack and with React, now you have to set your modes for building for production. So with React, like we saw with these dev tools with measuring performance, it actually, when you're in dev mode, it'll give you all these additional stuff to help you debug, troubleshoot, test your React applications. But if you build for production, it is able to pull that stuff out, make a smaller and faster build than you would get in development mode. And when you're doing the build, all you have to do is set the node environment to production, and you get instant free 2 to 8 times performance boosts just by adding that one line to your code. So to test this, we no longer have access to dev tools once you put it into production mode. So we're just going to look at paint time, see how long it takes for that to get it onto the so we're in production mode, and let's take a look at how fast this goes then. And we're looking at about 5.9 milliseconds then in production mode. Even smaller, even faster. Whoa. Okay, so you might be asking yourself, Joe, what about stateless components? I get asked about stateless components almost every time I give this talk. And you would think that stateless components would increase performance in a React application. And a stateless component, in case you don't know, is just it's a JavaScript function that returns JSX. There's no state in it, there's no props, no lifecycle methods. It's just a function that returns JSX. But behind the scenes, React is actually adding a regular React component wrapper around that stateless component, and it's behaving the same exact way as a regular component. Dan Abramov has said that they would be in the future adding performance optimizations to stateless components, so you should still do them. They're also much easier to write, much easier to test, much easier to maintain, better all around. So whenever you can write a stateless component, please do. Just note there is currently no performance gains for doing that, even though you think there would be. Okay, so that's most of the React specific stuff. But I want to go a little bit further into like the whole React ecosystem and some of the stuff that we do, I do daily in order to like make our React applications go faster. So one of the big things I think that all of us do use is Webpack. We use our Webpack bundler to build our React applications. And there's some huge gains that can be made in our Webpack files for making our React apps faster. So the first thing that we do is we analyze our Webpack bundles. So what does that mean? So I know it's a big joke in JavaScript how our node modules are insane. And a lot of times, if you're not bundling your Webpack files correctly, you're going to be including a lot of extra crap in your Webpack bundle that you might expect. And to make your web apps go faster, the smaller you can make your Webpack bundles, the faster it can get through the internet tubes to the client. So something we're constantly doing is auditing our Webpack bundles for size. We'll go through and make sure that we're pulling out anything we don't think we need, like, oh, you have Bluebird in there? Like, that's massive. Do we actually need Bluebird? Can we start using native promises? Or, oh, jQuery, that's massive. Can we pull like just a single part of that? Or can we scrap that altogether? We've even been able to audit other people's libraries that we're pulling in, that we're importing, and then asking them to go that. So we're able to make the entire application go faster by analyzing the Webpack bundles. So we do that. We use a tool called Webpack Bundle Analyzer. And this is a GIF of how it works. It allows you to just visually navigate your Webpack bundle, which is amazing. We've built this into our build process now. So every time you do a build, it actually will show you your Webpack size. Kind of do a quick little overview of like what's going on in your application. I can show you zipped, gzipped, or just unzipped files. Notice here on the left side is your node modules, and on the right, so here in blue is like your actual source files that you've written. This will also help us catch things too, like maybe we're importing things incorrectly in our CSS files, or maybe we have massive files that need to be set off to a CDN or can be offloaded. This is a huge opportunity to catch those and pull those out before they get out of control. Okay. So profile often, yeah, we do profiles periodically, especially if we like get code or anytime I look at somebody else's code or receive something or take a look at it, we haven't looked at it in a couple months, we're constantly taking a look at it, making sure that we're making those as small as possible. But I do want to say, and I think this is probably the most important part of this, is that making your application work is way more important than making it fast. So I mentioned this at the beginning of the talk too, that typically, like how I got into this was not just jumping in and making my applications fast. It came out of necessity. And I recommend for most people too to not worry about performance until you have a performance issue. Firstly, because it's hard to troubleshoot. If there's not a performance issue, what are you looking for? It's hard to keep an eye out for that stuff. Something we do too, if we hear or we notice that stuff, we will start digging in, but otherwise we don't. I value an application that works and is out the door than one that's perfect and you're just sitting on every time. I value action over perfection every time. And typically with performance too, it's something you can improve or something you can dig into too, especially with all these tools. All right, cool. So let's do a quick little let's do a quick little recap here. So make sure you're using your keys correctly. Make sure you're managing when the component should update. Extending pure components if you can. That means if you're using shallow props or state structure. Use immutable data. And you can use immutable data libraries like immutable.js, or you can use JavaScript hacks to try to make immutable data on your own. Up to you. And then lastly, making sure you're built for production. Get some huge gains for free on there. I love this little recap button. It like magically makes people perk up. I don't know why. It like reminds people, oh, okay, great. This is important parts. And then analyze your Webpack bundles. So use the NPM package we have linked in there. Profile often. And the short version, right? Rendering only when you need to. And then making it work and making it fast. I think this looks like a runner farting, but it's supposed to be a speed boost. I don't know. Okay, cool. Let's see. Well, thank you. That was fast, painless. Put this up here.
All right. Let's hang out over here.
Ouch.
Thank you. Okay. One question I have is, which of these things do you feel like you get the most bang for your buck? Like the lowest effort in terms of like least refactoring and scary code changes?
Yeah, I mean, the keys one's probably the easiest. Yeah, there's a... So the scary part too with some of these, especially like should component update or using pure components, is that things could change if people don't understand it. So for example, if you have a like flat pure component and maybe you have a new developer that comes in, doesn't really understand React, they could change the props and make them deeply nested. And if your pure component isn't ready for that, it's not going to update on DOM, and they might be sitting there for hours trying to figure that out. Yeah, so it could lead to trouble in the future. Or maybe you don't like maybe you just start changing them all to pure components, and maybe you don't fully understand the data structure flowing through the top too, and you start seeing that updates aren't changing as when they're expected to. I mean, I think the key, building for production is super easy, and I think the key is probably the easiest one to do too. Yeah.
All right, one question from the audience. What about pure function components? Any performance tips there?
Pure function components.
Pure, not pure. Oh.
Same? Tomato, tomato.
Pure.
Let's see here. Is that different than...
I have a picture if you want me to show you.
Oh yeah, I'd love that. That'd be great.
I'll describe the characters. Import React from React. Return.
It looks like just a stateless component. Yeah, so it's just a function that's returning JSX. Yeah, so that was that stateless component part too. So yeah, that's the same thing. So yeah, it's a function that returns JSX. Even though it looks like it's just a function, React still is behind the scenes, still wrapping that with a regular React component. So there's still no performance gains on that.
All right.
Yeah, good question.
Thank you so much.
Yeah, thank you. You made it.